We've got some fresh images of 3I Atlas interstellar object.
Think it might not be your typical space rock or maybe any kind of rock.
This may actually be a piece of alien technology.
3I Atlas is currently making its way through our solar system. The third known visitor from outside our solar system is drawing attention not just for where it came from, but how it's behaving as it gets closer to Mars. Discovered on July 1st, 2025, by the Atlas Survey. It's confirmed to be on a hyperbolic trajectory, meaning it's not gravitationally bound to the Sun. 3I Atlas is unusually active at a great distance from the Sun, showing a strong CO2-dominated coma. This suggests it's venting gas in ways scientists don't usually see in comets from our system. The problem is, however, that 3I Atlas is soon set to disappear from NASA telescope view, as its trajectory takes it around the opposite side of the Sun. From Earth's perspective, it won't be visible from Earth-based telescopes, and we won't be able to see it from Earth when it's at its most active. But what if something out there knows exactly what we're planning? 3I Atlas. It's moving faster than anything we've ever tracked from interstellar space. At first, it seemed like a rare scientific treat, a rogue comet from another star system. But as it moves closer to Mars, it's starting to behave in ways no natural object should, and it's getting dangerously close, just as Elon Musk and NASA prepare its most ambitious plans for the Red Planet. For decades, Mars has captivated our imagination, a cold, dusty world that still feels like it's hiding secrets beneath its crimson surface. And now, as NASA prepares to send humans to Mars, but what if it's not empty? And what if something got there first? Overs like Perseverance are digging into Mars' ancient riverbeds for signs of microbial life. Crewed missions are planned for the late 2030s or early 2040s, aiming to build long-term habitats, test in-situ fuel production, and eventually make Mars humanity's second home. But should we be worried about 3I/ATLAS getting close to Mars? The impact could release the energy of 2 million megatons of TNT. The blast would carve a crater 60 kilometers wide. It would obliterate decades of scientific hardware. Perseverance, Ingenuity, and the Mars Reconnaissance Orbiter would all be gone. In their recent studies, researchers employed the telescope's multi-object spectrograph to analyze the wavelengths of light emitted by 3I/ATLAS, which provided details about its chemical composition and how its materials are changing during its passage through the solar system. We were excited to see the growth of the tail, suggesting a change in the particles from the previous Gemini images, and we got our first glimpse of the chemistry from the spectrum, said Karen Meach. This offers a second reason to use HiRISE within the next month. Beyond capturing images of 3I/ATLAS's nucleus and dust cloud, HiRISE could also scan Mars for any precursor objects, smaller bodies that might be traveling ahead of 3I/ATLAS, and passing even closer to the planet. Ground-based telescopes near Earth aren't capable of detecting sunlight reflected from objects smaller than 100 meters, which happens to be about the maximum size of any space probe humans have launched to date. If 3I Atlas is a technological object, this short MOID makes it easy for a precursor mini-probe to reach Mars. In addition, an orbit correction by 10 to 15 kilometers per second during the month of September 2025 could shrink the closest approach distance of 3I Atlas from Mars to zero. As calculated in Figure 4 of my paper with Adam Hibbard and Adam Crowell, said Avi Loeb just broke years of silence about something that's got the entire astronomy community freaking out. This Harvard professor has been studying space rocks for decades. He's seen comets, asteroids, and all kinds of weird stuff flying around out there. But 3I/Atlas is different, really different. In fact, the reason Avi Loeb finally breaks his silence about 3I/Atlas is because it defies every conventional explanation he's ever encountered. Loeb created what he calls the Loeb scale, just to rate this thing. 0 means it's totally natural, like any normal comet you'd see in textbooks. 10 means confirmed alien tech that's actively trying to talk to us. He put 3, I/Atlas, at a 4. That's never happened before with any space object, ever. Think about what that means. A mainstream scientist at one of the world's top universities just said there's a 40% chance we're looking at actual alien technology, not some fringe researcher making wild claims. This is Avi Loeb, the guy who's published hundreds of peer-reviewed papers on astrophysics and cosmology. The stock market is already getting nervous. Financial analysts are running computer models on what happens if alien tech gets confirmed. The results aren't pretty. Our entire economic system runs on one basic assumption: humans are alone in the universe. Take that away and everything falls apart. Insurance companies base their risk assessments on predictable, Earth-based threats. Investment firms plan decades ahead, assuming no outside interference from advanced civilizations. Defense contractors build weapons for human-level conflicts. If aliens exist with interstellar travel capabilities, those calculations become worthless overnight. Lately, Avi Loeb has sparked interest in Comet Swan, suggesting it could be an interstellar object worthy of closer scientific study. Are Comet Swan and 3I/ATLAS harbingers of a new cosmic era, where alien objects routinely visit or even interfere with planets in our solar system? At first glance, Comet SWAN appeared like many comets before it, with a faint, fuzzy blotch in the solar neighborhood gradually brightening. Discovered through imagery from SOHO's SWAN instrument on September 11th, 2025, amateur and professional astronomers alike have noted its rising magnitude, about +7 and a tail of roughly 2 degrees across the sky. But as the observations piled up, astronomers and scientists started to discover something strange. SWAN's trajectory didn't align with ATLAS or any known comet family. Some of the weirdest features of Comet SWAN is its inclination, perihelion distance, and orbital period point to a path that's different from what those other comets have visited before. It moved from a completely different path than ATLAS, coming from a direction that seems unconnected to anything familiar. There were many strange clues that pointed towards Swan as a new interstellar object with a tail that is 100 times larger than 3I/Atlas's. It was located too close to the Sun, within about 30 degrees for many telescopes, before its discovery. This means it was obscured until it brightened enough. This has made it harder for the arrival path to be traced. Estimates place Swan's perihelion at about 0.5 astronomical units or 75 million kilometers from the Sun. Its eccentricity is very high, so it is on a bound, though extremely elongated path. The orbital period is quite uncertain, as some estimates say it's around 1,400 years or more, depending on which observational method is used. Aphelion is the farthest distance, and is correspondingly very large, up to hundreds to thousands of astronomical units. Observers have also noticed that SWAN comes from a completely different sector in the sky than Atlas. While Atlas's inbound direction is related to the Sagittarius area, toward the center of the Milky Way, SWAN's original vector seems to come from a different constellation, making the origins completely unrelated. But there have been some expected aspects and hidden secrets. Even before reaching perihelion, SWAN's tail was pretty long, about 2 degrees as seen in images, a feature that immediately sparked comparisons and led to the stunning realization of its scale compared to 3I/ATLAS. Its brightness rose rapidly. For many comets, such long tails are rare at that early stage. Comets only grow a massive tail after strong outgassing and dust release. Since SWAN was first seen, when it was close to the Sun and under solar glare. Many of the early orbital calculations have high uncertainty. The longest time that scientists have observed it is several days to a couple of weeks, so that makes it hard to figure out whether SWAN is coming into the inner solar system for the first time or not. When astronomers compared the orbital paths of ATLAS and comet SWAN, an unexpected and perplexing difference emerged, one that challenges our understanding of interstellar visitors. These two objects do not share the same trajectory or approach vector, and there's no indication they originated from the same region of space. Though they arrived within a short time of each other, they came from vastly different directions in the sky. Their orbits are fundamentally distinct, setting them worlds apart in motion. 3I Atlas follows a hyperbolic orbit, tilted roughly 175 degrees relative to the ecliptic plane. This means it's moving retrograde, almost directly against the direction most planets orbit. In contrast, SWAN's orbit is elongated but not truly interstellar. Its eccentricity falls just below 1, indicating it remains gravitationally bound to the solar system despite its stretched-out path. Put simply, ATLAS comes in nearly head-on, moving against the flow of the solar system from a steep, retrograde angle. Meanwhile, SWAN travels close to the ecliptic plane with only a slight tilt. Other differences stand out as well. Atlas's hyperbolic orbit means it will pass through once and never return. SWAN's near-parabolic orbit suggests it is bound and could be seen again, perhaps thousands of years from now, assuming its path isn't significantly altered. Additionally, Atlas approaches the Sun more closely, while SWAN ventures inside Venus's orbit before nearing the Sun's hotter regions. SWAN has already displayed a visible tail about 2 to 2.5 degrees long in the sky, shining at a magnitude of +6 to +7, bright enough for binocular viewing under clear conditions. The disparity becomes even more striking when examining their comas. SWAN's tail is nearly 100 times larger than Atlas's. This is not just an intriguing difference. It has captivated scientists, sparking intense study and debate. Given their starkly different origins, one nearly retrograde, the other nearly prograde near the ecliptic, and their close arrival times, it's difficult to dismiss their coincidence as mere chance. This unusual event has led some to speculate about mysterious forces at work in the solar system, even raising questions about extraterrestrial activity. What these two interstellar objects make clear is that our current understanding of the solar system may need a serious rethink. Could there be streams of interstellar debris flowing through? Are distant planetary systems ejecting countless bodies in all directions? Or is there some unknown cosmic mechanism at play? These possibilities have left scientists both intrigued and unsettled. The implications carry a weight of uncertainty and risk. What other strange visitors might come? If Atlas and SWAN can arrive from opposite directions, what else could appear unexpectedly near our planet? NASA recently held an unprecedented emergency briefing following an attempted contact with 3 I/ATLAS, only the third known interstellar object passing through our solar system. Unlike typical comets, including the well-studied comet SWAN, this mysterious visitor responded to NASA's powerful radio, radar, and laser signals with unusual frequency shifts and structured radio pulses that advanced AI systems identified as potentially artificial. This discovery prompted a rapid, high-level response involving not only NASA's top scientists, but also military space agencies, reflecting the serious national security implications of encountering an object that might be an extraterrestrial probe. If random comets can enter our solar system from wildly different galactic directions, then our solar neighborhood is far more exposed than we've supposed. These aren't just pretty fireballs in the sky. but they actually carry risk. A large comet can come from anywhere at high velocity and deliver catastrophic destruction on any planet, especially if observed too late. Many astronomers have agreed the most frightening part is that they arrive without warning. Long-period comets, like SWAN, now recognized as a potential interstellar object with a tail 100 times larger than 3I/ATLAS, are especially dangerous in this aspect. Since SWAN's orbit is long, often highly inclined, and also affected by forces outside the well-understood dominated paths of asteroids, astronomers will only see them when they are within the inner solar system. Once this new interstellar object was noticed, it was too late to mount much of a response. If SWAN wasn't a harmless comet, but a dangerous fireball, this would have affected the solar system as we know it. The unsettling truth is that Comet SWAN and ATLAS are not related. Although they appeared in the solar system in close cosmic timing, they have different origins, velocities, and trajectories. This provides a second motivation for using HiRISE within a month. In addition to imaging the nucleus and dust cloud of 3I/ATLAS, HiRISE could image Mars in search for any precursor objects that precede 3I/ATLAS and get closer to Mars than the main object. Near-Earth telescopes cannot detect the reflection of sunlight from precursor objects that are smaller than 100 meters, the upper limit on the size of all space probes launched by humans so far. This is a milestone, the 20th official SWAN comet so far, scientists said. It was an easy comet for detection due to sufficient brightness in the ultraviolet band and location in the SWAN images, exactly in its center. But it was difficult due to the very close location to the Sun and angular motion, which is very close to the Sun's motion in SWAN images. If the comet continues to behave as it does now, we will have a great comet in October, also in the Northern Hemisphere. Astrophotographer Gerald Raymond told Universe Today. By comparing recent observations, NASA has been able to determine an orbit. It suggests this comet completes an orbit around the Sun every 22,554 years. This means that if you are able to see the new comet, SWAN, using binoculars or with a camera, this will be a once-in-a-lifetime sighting. If the comet survives this pass, it will return around year 24,579. Recent observations of Comet SWANR2 have provided valuable insights into its composition and behavior as it travels through our solar system. Because cameras are more sensitive than the human eye, the long tail captured in images of Comet SWANR2 may not be visible to the naked eye. Matiazzo noted that the comet's brightness has risen to about magnitude 6.9, though some observers believe it could be slightly brighter. Although the comet is currently very low on the western horizon, viewers in the southern U.S. may soon catch a glimpse as it gradually rises higher each evening, provided the comet remains intact. For example, an observer in Zacatecas, Mexico, successfully photographed Comet SWANR2, and Mike Olison faintly captured it from Tucson, Arizona, on September 13th, despite its low position. Meanwhile, observers in the southern hemisphere have had the advantage of early views of this unexpected celestial visitor, offering valuable data that scientists are eagerly analyzing to better understand its origins and composition. Comet SWANR2 was a non-periodic comet first observed on September 11, 2025, by amateur astronomer Vladimir Bezugly using the SWAN instrument aboard the SOHO spacecraft. Initially located in the constellation Virgo, it was best visible from the southern hemisphere, particularly near the star Spica. The comet brightened rapidly, reaching an apparent magnitude of plus 6.9 by September 17th, making it observable with binoculars. Scientists said NASA believes that Comet SWA-NR2's disintegration was due to its small size and the intense heat and radiation from the Sun. Dr. Qicheng Zhang, a postdoctoral astronomer at Lowell Observatory, explained that small comets can become unstable as they approach the Sun. The outgassing of volatile materials can cause them to spin rapidly, leading to structural failure. Astrophysicist Carl Battams from the U.S. Naval Research Laboratory added that the comet's rapid fading suggests it may have broken apart, leaving behind only a dusty debris trail. SWAN's advantage is its sensitivity to Lyman alpha ultraviolet emission from hydrogen, which is abundant in cometary water vapor. As comets approach the Sun and their ices sublimate, SWAN can detect the resulting hydrogen glow even when the comet itself is too close to the Sun for ground-based telescopes to see universetoday.com. In SWANR2's case, the comet was coming from the direction of the Sun relative to Earth, lurking in twilight. It remained hidden until just before discovery, because early August through early September. Indeed, SWANR2 was only spotted one day before perihelion, as it finally crept far enough from the Sun's vicinity to stand out in SWAN's all-sky view glowing tail with chances of outbursts. Comet SWANR2 has offered a modest visual display. As it passed around the Sun, it began to extend a long tail of dust and gas that surprisingly leads the comet on its way out of the solar system. Source: universetoday.com. By mid-September, images revealed a tail stretching about 2.5 degrees across the sky, approximately 20 million kilometers in length, trailing behind the comet's greenish coma. Source: earthsky.org. The characteristic green color seen in the coma and tail is caused by vaporizing diatomic carbon and cyanide gases, making SWANR2's appearance reminiscent of other so-called emerald comets. When SWANR2 first appeared, it sparked an intriguing question. Could it be an interstellar comet? Another visitor from beyond, like Oumuamua or Borisov? Its late discovery hinted at a steep, possibly hyperbolic trajectory, and early orbital calculations showed eccentricities very close to 1.000, adding to the uncertainty. Naturally, this fueled speculation. Avi Loeb, the Harvard astronomer known for his interest in interstellar phenomena and extraterrestrial possibilities, was quick to consider SWANR2's origins. As soon as I learned about SWAN, I was curious whether it might have originated from 3I/ATLAS, Loeb remarked. As comet SWANR2 continues its journey away from the Sun, it leaves us with more questions than answers, reminding us that the cosmos is full of mysteries waiting to be unraveled. Stay tuned, because the story of this emerald visitor is far from over.